Hey guys, today we are going to kind of bring everything together and talk about rational inequalities. So rational inequalities are going to be very similar to both of the things we've done so far. It's going to look a lot like the polynomial inequalities, but it's really going to look like when we talked about using a sign chart to graph a rational inequality or graph a rational function. Okay, so before when we had a polynomial inequality, we only needed the x-intercept because that's for the only place that it could be switching from negative to positive or positive to negative. Okay, but we know that rationals can also switch at a vertical asymptote. So let's do an example problem. So if I had this rational inequality, x minus 3 all over x plus 2 less than or equal to 0. What you have to do here first is you need to find both your x-intercepts and any vertical asymptotes. So remember, when we find x-intercepts, all we do there is we set the top equal to 0, and that's going to be an x-intercept, and a vertical asymptote is we set the bottom equal to 0, and that's going to be a vertical asymptote. So if I do that here, and I drew my sign chart, so I'm going to go ahead and make a line over here, I would know that I would have an x-intercept if I set the top equal to 0, so I'd have an x-intercept at positive 3. And if I set my bottom equal to 0, I would have a vertical asymptote at x equals to negative 2. So we do the same thing that we used to do with my sign charts when I decide and plug in a number that fits this range. So something less than negative 2 would be like negative 3. So if I plug in negative 3 into my inequality, I'd get negative over a negative, which gets me a positive. If I plug in a number in between negative 2 and 3, like 0, I would have a negative over a positive, which would make that into a whole negative number. And finally, a number bigger than 3, so like 4 or 5. If I plug that in, I'd get a top of positive and a bottom of positive. So positive divided by a positive is a positive. So now I have my sign chart filled out. I go back to my original inequality, and I need to know where is this going to be less than, so that's a negative number, or equal to 0. So this is the only thing that changes on this. We know that my interval would be this one right here. So I'd go from negative 2 to 3. That's where it's negative. I know that there's a 0 at 3, so I can put, since it's equal to, I can put the square bracket. But the hardest part about this is that you can never, ever, ever have your graph equal to this vertical asymptote. It's approaching that number. So if I look right here, it can't equal to 0 at that point, so I would use a parenthesis bracket. So if you need to make a note here, a vertical asymptote will never, ever, ever be a square bracket. It's always going to be parentheses. So this would be my final answer here. That is where my graph is less than or equal to 0. Okay? The only other way that they could switch this up is to give you something that looks like this, where you don't have it equal to 0. So we have to make sure we move everything to one side so my inequality is set equal to 0. So I'm going to go ahead and add 2 to both sides. So I'd have x minus 3 over x plus 2 is greater than or equal to 0. Now before I can do anything with this, I'm going to have to make this into one inequality. And so I'm going to have to find a common denominator between these two. So this one was over 1, so my common denominator here would be x plus 2. So I have to multiply this number by x plus 2 over x plus 2. Now I can add them together because they have a common denominator. And I can go ahead and distribute that 2 into that second term. So I would have that this expression was x minus 3 over x plus 2 plus 2x plus 4 all over x plus 2. Okay, and so now at this point, we have common denominators. I can add this up. So my top would be 3x's all together, minus, or plus 1, sorry, I don't know how to add today, all over x plus 2, or just adding fractions up. And so now I can do the same thing that I just did here, or did on the problem before. So I can draw my sign chart and figure out where my vertical asymptotes and everything are. So right here I would have a x-intercept, or a 0, at negative 1/3. And I would have a vertical asymptote at negative 2. So that's what I'm going to put on my sign chart. I have negative 2. Remember, that's a vertical asymptote, so sometimes it might be helpful to kind of draw that line in. And then negative 1/3. And then I go ahead and I plug in some test points in there. So I know a number less than negative 2 would be like negative 3. So I'd get a negative on the top and a negative on the bottom, which makes a positive number. A number in between these two might be like -1. So if I plug in -1 into this expression, and again I'm going to use the one that I already solved down, so that'd be a negative on the top and a positive on the bottom, which makes it negative altogether. And then finally a number bigger than -1/3, like 0 or 1, I would get a positive on the top and a positive on the bottom, so a positive expression overall. So now I go back to my expression and I look and I say, okay, well I need it to be bigger than 0, so that is a positive number. And I look on my graph where I'm positive, and these two intervals are where I'm positive. And since we don't even have a line underneath, I don't have to worry about asymptotes. They're all going to be parentheses. And then I do my little union, so I can say that there's 2 places where this graph is positive. And that's all we got to do here.